All right,
Thank you,
so
Jen.
good evening, everyone in India, and good morning to those of you in North America and other places where it's morning for us here right now. Uh, Welcome to week 6 of your introduction to astrobiology workshop. And today's topic is planetary protection and space policy and their relevance to astrobiology. So we are honored, and I am really excited to share the stage today with Dr. Alissa Haddaji from Harvard University. She is a lecturer there on space policy, and she will be actually continuing the talk today after I have described to you what I do at JPL. So I do work in the Planetary Protection Division of JPL, but and I have already spoken to you, so you probably already know me from Plate Tectonics talk. But I'd like to say a few words about Dr. Haddaji. Dr. Haddaji is a faculty researcher and a lecturer on space law and policy at Harvard Law School, a United Nations Officer of Outer Space Affairs and Space for Women Network mentor, and the former Planetary Protection Project Officer of the Committee on Space Research, COSPAR, which is the committee that basically laid down the policy laws for planetary protection internationally. She has coordinated and she has co-written the International Planetary Protection Handbook and led the planetary protection workshops in China, in Japan, Europe, and the United States as part of the European Commission's PROS project. So she will be presenting the legal and policy aspects of planetary protection, and she'll share the lessons she has learned in the planetary protection management so far. So how did this come to be is something that you will learn from Dr. Haddaji more. But at NASA, we like to call ourselves as the guardians of galaxy because we are protecting all of the planets all of the time. Something that was coined by John Rummel, who was a planetary protection officer for NASA headquarters in one of his talks. And what does it really mean, protecting all of the planets all of the time? So as we explore space and as we explore other planets, send robotic missions there and send human astronauts there, or in the future, as we send human astronaut explorers further down in the solar system, we want to make sure that we are not forward contaminating these planets with any of the Earth microorganisms, because we want to be able to study the evolution of life, and we are still looking for how that evolution of life took place, and we still want to find that other example of life in other places in the solar system. But if we are bringing microbes from Earth, then that exploring or that question that we have as explorers may become redundant. So we want to take care that we are not forward contaminating other planets with Earth organics or Earth microbes. And also when we are bringing samples back from these planets back to Earth, or we have astronauts coming back to Earth after their missions, we want to make sure that we are not bringing anything that is potentially dangerous and extraterrestrial in origin, that is a microbe or that is some kind of life form that is not from Earth, without really knowing anything about it or how it can interact with the Earth's environment and Earth's living organisms. So that's what planetary protection does. And it has all of the space agencies, they have this goal that when they send out their rovers, they have to make sure that they are thoroughly decontaminated. And we have various procedures for that. So at NASA, we have the NASA standard assay, where every part or every component of every rover or robotic mission that is built undergoes several processes of cleaning and isolation of whatever microbes are growing on them. And these are usually built on clean rooms that where people, engineers building them, they have to wear, they have to robe completely. They have to wear these bunny suits and gloves and hats so that they do not contaminate any of the parts that are being built. But then, of course, as we know more, as we learn more about microbiology, we know that Earth is, there is nowhere on Earth where you don't find some kind of microbes. So yes, as we build them, it's a process of decontaminating these components through various procedures to make sure that the bioburden on these components of the rovers are not carrying a lot of load that could potentially contaminate another planet. So planetary protection laws, or at least the current policy, states that you cannot have anything, especially the microbes that usually survive these procedures are the endospore forming organisms that we see, the bacteria. And then there are certain kinds of bacteria that form these endospores. So planetary protection policies has a number that, okay, it cannot be more than 500,000 for any rover that is being sent to outer space or to another planet. And these laws are usually, of course, revised by different committee members, something that we'll again learn from the policy side of things. But at NASA JPL, these two pictures, it's showing you on my right, this is actually from the drill bits that was part of the Mars 2020 mission. This is where you take swabs and basically try and identify the isolates that have been isolated from different parts of the rover. And this picture here on the left is from the InSight mission. You can see the engineer there taking a swab of one of the regular procedures that it undergoes. So this process is something that as the rover is being built, as the different components of the rover is being built, it continues. It's a process. And then before everything is packed up usually at the Kennedy Space Center in Florida, that's when they run through the last procedures of swabbing everything and isolating everything and making sure that the bioburden on the rover is not above the law, that whatever the policy or whatever the laws that we have to comply with, so as to not contaminate any planet. So a good way to understand this is I found this video which basically will talk about what was done during the assembling of the Mars 2020 rover at JPL. And I wanted to watch this video as a class together because it shows a good procedure, and also the Planetary Protection Officer at NASA headquarters, Lisa Pratt, is walking us through it. Just so that we can get a good understanding of what goes on in planetary protection and what we do. So it's a pretty long video, but we are not going to watch the whole part of it. We'll just watch the first 7.5 minutes, and then I'll talk more about what I do at JPL as part of planetary protection.
When we return a sample from Mars, could we identify life in that sample?
Can we go there and sustain ourselves without harming Mars if there's something on Mars that could be harmed?
Hi, I'm Jim Green, Chief Scientist at NASA, and this is Gravity Assist. On this season of Gravity Assist, we're looking for life beyond Earth. I'm here with Dr. Lisa Pratt, and she's NASA's Planetary Protection Officer. She plays a critical role in overseeing and approving how NASA implements planetary protection requirements for all our planetary missions, both robotic and human spacecraft. Welcome, Lisa, to Gravity Assist.
Hey, thank you, Jim.
You know, you've had a distinguished career in biogeochemistry and astrobiology, you know, and the Planetary Protection Officer name, that sounds really cool. In fact, I received letters from kids all over the world, and one of them called your position the Guardian of the Galaxy. So I can't help but think that every time I talk to you. But let's start with the basics. What is planetary protection?
Jim, I wish I could tell you that I was, in fact, the guardian of the galaxy, but the reality is a little more mundane. Planetary protection is focused on limiting biological contamination of other worlds with terrestrial organisms. That's organisms from Earth, and preventing the return of harmful potential extraterrestrial organisms or just organic materials when samples are returned to Earth during robotic sample return, or in the future, when astronauts come back to Earth from exploration missions to other worlds.
We send things all over the place, and the next big mission is, of course, Perseverance, and it's going to Mars. And so when NASA wants to send a new rover to Mars, what do you do?
Well, Jim, right from the very earliest phase of mission design, when that light bulb first comes on with an idea for a new mission, the Office of Planetary Protection provides guidance to the engineering team on heat sterilization or alternative chemical cleaning methods such as vapor hydrogen peroxide, because some spacecraft materials can be cleaned and others cannot. And we want to be sure that we're designing a spacecraft that'll tolerate the cleaning procedures necessary to go to the three places we care about right now most deeply in terms of contamination, and that's Mars, Enceladus, and Europa. And when we have a mission that's being assembled for one of those locations, then there's actually an independent auditor from our office that travels to all the facilities where parts like solar panels or parachutes are being manufactured. And we take samples to determine the level of biological cleanliness. And every day, I actually review data on the number of spores being sampled and detected on Perseverance as we get ready for launch. And we use that to tell us if we need to do additional cleaning or what we call bioburden reduction to get ready for launch.
So Lisa, what is a spore exactly? Is it biologically made up of many different things?
A spore is a tiny microscopic resting cell that only certain types of bacteria can make. And they make spores, a process called sporulation, when the environmental conditions get challenging and it looks like they're going to have to shut down. They're not going to continue to be active. But in the process of making that spore, that single cell entity, they wrap it in layers of highly resistant biopolymers. They seal it off, and thereby they create the possibility of that spore later breaking open and turning back into a viable organism that can replicate and grow. So the reason and this goes back to Viking, it's really the Viking planetary protection biologists that thought this through and said, of all of the entities known on Earth that are biological, the only thing we think that could get on a spacecraft, not be seen in an inspection, and stay viable would be a hardy spore. So we don't even monitor all of the spores, which you would be monitoring if you were making medical devices like implants and things like that. For us, we take a wipe of a spacecraft surface, or we take a tiny little swab that looks like a slightly large Q-tip, and then we heat shock that sample to kill the wimpy organisms, because we only want to know how much contamination is there that could survive the journey, launch, travel, cruise stage, and the landing and the exposure to another planet. Those are the NASA standard assay, the NSA spores. There are international guidelines for spore cleanliness, and the total mission requirement for all spacecraft elements impacting Mars is 500,000 spores, including the rover, aeroshell, descent stage, and parachute. That sounds like a lot, but the requirement is less than 300 spores per square meter of exposed rover surface. Spores are tiny, barely visible with a light microscope. So 300 spores per square meter can be scaled up and visualized as just 28 tennis balls on an entire football field. That's thousands of times less than what our spacecraft would carry if we didn't build them in a clean room facility, if we didn't constantly wipe them with cleaning fluids specific to biological cleanliness, like 70% isopropyl alcohol, which is what we all now read the labels on our hand sanitizer under the current pandemic to make sure that we're using at least 70%. It's just what we use on spacecraft.
All right, so that's about the gist of it, of what planetary protection entails. And I just wanted to stop sharing and talk about what I do at JPL. So planetary protection has evolved. Our procedures have evolved over the years. So we definitely want to decontaminate our rovers. But whatever we are isolating from these spacecraft, we don't just discard them. We have actually stored them away in -80 freezers. And part of my job is to help create a database of all the spacecraft microbiome that have been isolated since the 1970s, since the Viking mission. So I'm focusing only on the Mars missions, all the Mars rovers, but just know that planetary protection procedures are applied to all the rovers going out to all the planets, and also, of course, to the International Space Station. But my part of the work is to help create that database of all the microbes that have been isolated from spacecrafts or rovers that have been sent to Mars. And over the years, the isolates, the way that we would identify them were via various methods of sequencing, so 16S sequencing and other modes that would tell us what these are. But we have evolved, and now the latest technology, it seems hospitals also seem to really like it, is the mass spec identification, or something called the MALDI-TOF, which is what was used for identifying all the isolates that were swabbed off the Mars 2020 rover. So I actually use the same technique of mass spec, of characterizing all the isolates that I have from the previous missions that are sitting there in the -80 freezers. So I basically revive them, I culture them every day, and then do the protein extraction, and then run it through the MALDI-TOF to get our identification. And as we do this, we are building up a database for NASA that can be used internally as the agency progresses towards other missions, of having that repository of all the microbes that we usually see with spacecraft, or we see on spacecraft. And some of the interesting ones, we obviously try, we want to get them on a whole, we want to get the whole genome sequence of these, because oftentimes we also come across very interesting bacteria that do some funny things that you may not see in bacteria and elsewhere in the environment. So this is the first database of its kind. If you're in microbiology and you're working as an environmental microbiologist, then you would know that yes, soil scientists have their own repository of microbiome that is associated with soils, or microbiome that's associated with crops. Or if you're working in healthcare, then doctors are familiar with the microbes that they often find in hospitals, or things that are associated with patient samples. So this would be the first time that NASA would be able to say, okay, you know, we have a repository of microbiome that you just see that's associated with spacecraft, or having that spacecraft microbiome. So yeah, that's about the gist of what planetary protection does. And there are different levels of it. So what you saw on the video are the planetary protection engineers who work when a particular mission is being developed, or robots or rovers are being developed. And then I work on the science side of things, that once we have those isolates, then what are the other things that we can learn so that we can better our methods moving on in the future, our sterilization methods specifically. So we are learning some new things, that it's not just the spore formers, but the non-spore formers are actually also quite problematic, and sometimes they can be extremophilic and can survive that journey, interplanetary journey to Mars. So we are learning more and more, and we are finding ways of how to go about the sterilization process. Of course, there's also a group at JPL within the planetary protection that specifically just works with biomolecules or organics that are not whole cells, but these could just be say leftovers or DNA pieces of DNA just sitting on the spacecraft, that is also something that we don't want traveling to Mars or other planets, because that would, again, jeopardize our mission of isolating or finding something unique on another planet. So that's a whole different group that does that study, and that's very fascinating. So with this, I will hand over the stage to Dr. Haddaji, and excited to hear about the policy side of things.
Thank you. Thank you very much, Afshin, and I'm excited to talk to all of you. I first would like to thank Afshin and Sid and Jen for inviting me today. It is exciting to share some knowledge about the policy and legal sides of planetary protection. And so just for you to know, in terms of how the Q&A is going to work, I've planned for about an hour focusing on the policy and legal sides of planet protection, then about 15 minutes, which is my whole third part, on places where you can find that knowledge, the PowerPoints that I'm using, and all the presentations and the handbooks that I will be referring to. There is tons of information out there about planetary protection, and it's very well explained. And so I will share some links, also some ideas for conferences, groups that you can join if you're interested in it. There's a whole community out there, not only at NASA and the United States, but all around the world working on planet protection. So if it's something that is of interest to you, especially in connection with astrobiology, well, we'll be able to cover that. And so that will take an hour and 15 minutes approximately, and it will have about 15 to 20 minutes for Q&A. And so I've already seen some questions about the policy and legal aspects of planet protection, so I'm excited. Thank you, Lisa and Kristen. Hopefully the questions you've already put into the Q&A will be answered within my presentation. I've divided the work with Afshin, so all the questions regarding the biological side of planetary protection, she'll probably start answering them within the presentation, and in the chat just send you some answers. And on my side, I will try to cover as much as I can during the presentation and after it during the Q&A. And so I also want to warn you that this talk might be a little bit more text heavy than other talk that you might have had during this training, this course of yours, simply because it is policy and law, so we care about words a lot. And so we text and we write things. I try to keep my heavy slides to a minimum, so you're going to have some heavy slides, but not a lot of them at least. And I also would like just to say a quick word about the person who trained me in planetary protection. For the little personal story, I was already working on my PhD on space threat management, and so I focused on planetary protection and planetary defense, and I'll explain the difference between the two. And if you ever want to make me happy, if you ever cross path with me anywhere in the world, and you know the difference between planetary protection and planetary defense, you'll be my automatic friend. So while I was doing that research, I had the chance of being brought into COSPAR, the International Committee on Space Research, which I will talk about a lot because this is pretty much the international structure that deals with planetary protection. And through that work at COSPAR, I became the Planetary Protection Project Officer in charge of an international handbook. And I will try to share also with you the lessons that I've learned through the construction of this handbook and the do's and don'ts that we got. This way, if you end up working in astrobiology and not working on planetary protection per se, but at some point in your career need to know maybe the managerial challenges of planetary protection, well, this will be covered today. And if you want to focus on planetary protection in the future, you'll get all the links and all the information that you'll need to continue working on that topic. So that person who trained me is Dr. Gerard Kminek, who is the Planetary Protection Officer of the European Space Agency. In the video you've just seen, we saw Lisa Pratt, who's the Planetary Protection Officer at NASA, and there is one at the European Space Agency, and you have several other leads of planetary protection in different countries, where we presented the handbook and taught about the handbook and worked with those officers to develop an international framework to apply planetary protection guidelines. Also, training. There are tons of trainings available, so you feel free to check out NASA Planetary Protection, ESA Planetary Protection. You'll find plenty of information. That being said, most of the work that I'll be presenting is from the training that I've received from Dr. Kminek, but also from the work of PPOS. And the main website where you'll be able to find all the information that I'm sharing with you today is also the website of PPOS that I co-built with a wonderful web designer, because otherwise I don't know how to build websites. And so PPOS is planetary protection of solar system bodies, and I think it's that too many acronyms in the space world these days. But PPOS was funded by the European Commission to do a sort of state-of-the-art of where planetary protection is these days. And so, based on that, we today are going to talk about the policies and the laws referring to planet protection. And another word for policies, if you haven't worked a lot on space policies in general, it's to understand the strategies and the managerial structures. So who decides, how do they decide, how does it work to come up from scientific experiments to a decision-making process? That's what space policies are all about. Now I will start sharing my presentation. I'm checking the chat quickly. Yes, thank you for giving some information about Gerard. I am very happy. Okay, let's share now through this little window. Okay. And full screen, because otherwise that's not fun. Here we go. I think now you should be able to see it full screen. I added, obviously, Amity University. I'm very, very happy to have been invited to your course, and also the logo of Space for Women. I think you've already had some talks with and from Jen Blank, who's also a UNUSA Space for Women mentor. And I will have, I think, a couple of slides at the end of this presentation about the Space for Women project, because it is very important, and we want to make sure that those of you interested can reach out to us and get involved. So let's start with this introduction to international planetary protection policy. As I said, I'll give you an introduction to the policy, and then I will share those lessons learned, those do's and don'ts in planetary protection management. And finally, I will go through what to do, where to go to know more about planetary protection laws and policies. So, as I said, planetary protection, planetary defense, different things. On one side, you see bunny suits, and you think about the video that you've just seen that Afshin just presented on people decontaminating a spacecraft before it's sent into space. On the other hand, you see an asteroid hitting the Earth. Different things. Totally different things. So when you Google and you want to learn more about planetary protection, and unfortunately you type planetary defense, you're going to get a little confused. So planetary protection, all about decontamination, planetary defense, what to do if an asteroid impacts the Earth. As it turns out, I've been very lucky to be involved in both fields. And if in case, even though you're learning astrobiology and you might think that on asteroids there are not that many life forms available, well, but you still have this love into your heart about asteroids, there are legal and policy aspects of planetary defense that are out there as well. So on the first side, you have the International Planetary Protection Handbook that I had the pleasure and honor to coordinate, and it was published in 2019. It is relatively fresh, and I put in the presentation the link where you can download it for free. And on the right side, you have the Planetary Defense Legal Overview, and that is a group of 15 international lawyers working on the legal aspect of an asteroid coming towards Earth and what can you do to mitigate that threat. That, if you have any question about this, I've coordinated this group starting in 2017, and I'm be more than happy to answer planetary defense questions, maybe via email outside of this planetary protection dedicated course. So now that the distinction is made, let's understand better the goals of planetary protection. As Ashin introduced earlier, the goals of planetary protection is to ensure that scientific investigations related to the origin of life are not compromised. So we're going out there, we're trying to understand life in the universe, all about astrobiology, right? But to do that, it is really important to avoid false positives when trying to detect such life. So we want to avoid finding traces of life on another planet and realize that it's Earth's life brought there by the experiment itself. That's what we call false positives when we talk about planetary protection. Another very important point is to avoid long-term local changes that may impact future life detection efforts. And that's what we call those two, 1 and 2, forward contamination. We are bringing something to another planet, to a body, and we think there might be life. We're there to detect life, and we bring some life potentially ourselves, and we might bring something that could change the environment and also give us false positives. So that's why planetary protection exists. And finally, there is what is called backward contamination. So it's all about protecting the Earth from the potential hazard posed by extraterrestrial matter carried by a spacecraft returning from an interplanetary mission. And those are sample return missions. So this is one of those heavy text slides. I promise there are not that many of them, but it is interesting. To understand about planetary protection, we need to understand about its history. So I put there a quote from Joshua Lederberg, and I apologize if that's not the right pronunciation of his last name. The citation says, "We are in the awkward situation of being able to spoil certain possibilities for scientific investigations for considerable interval before we can constructively realize them. We urgently need to give some thoughts to the conservative measures needed to protect future scientific objectives on the moon and the planets." So this was published in Science in 1957. And one thing is, you've talked, I'm sure, a lot these past few weeks about astrobiology. An older word for it, which does not encompass all of astrobiology, but a good part of it, is exobiology. And that word, exobiology, was coined by Lederberg. Anyway, this man, Joshua, I'm going to call him Joshua. Joshua was received the same, I think a year prior, he received, no, I think the same year, he received the Nobel Prize for medicine for his research to understand the genome of microorganism. And when he looked at the understanding of the genome of microorganism, he realized that potentiality of forward and backward contamination. Not only him and a few other scientists had the same inquiry and had the same worries, especially if you look at the date, we're thinking 1958, it's a year after Sputnik. So we're sending things in space at this point, and we're thinking about going to the moon, we're thinking about going to other planets, and we want to make sure we're not ruining our own science. And here I will give you a little bit of the history now of this technocratic system. And if you do not know the word technocratic, if you go back to the origin of the word techno, the technology, the point is here that a technocratic system is a system led by scientists. And in the space system, a lot of the structures are technocratic. So you're going to have policies, so strategies, designed by space scientists. It is not going to be someone appointed from somewhere who knows about management and political science, who is going to make decisions about planetary protection. It is going to be someone who, with an entire committee of space scientists, knows those microbial organisms and knows how to better protect the environment of that planet and of Earth from them. So at this time, when I say it's a technocratic system is because the first voices that also rose this problem are the International Astronautical Federation, IAF, and UN COPIUS, so UN, United Nations, COPIUS, Committee on the Peaceful Uses of Outer Space, and finally the US National Academy of Sciences, NAS. And they raised those concerns those concerns and the fact that they rose those concerns created the Committee on Contamination by Extraterrestrial Exploration, CTEX. That was established by the International Council of Scientific Union, ICSU, in 1958. Again, as I said, the space world is full of acronyms, so I'm going to try to make you remember, especially COSPAR, and if you don't remember ICSU or CTEX, it's fine, you'll get those slides and you'll be able to work on them. So the International Council of Scientific Union, ICSU, adopted this special committee on contamination by extraterrestrial exploration code of conduct. And when they adopted this code of conduct, ICSU also established the International Committee on Space Research, COSPAR, in 1958. All of this is the same year. I hope you have an idea of that. The Sputnik and the launch of the space age, in a few amount of years, a lot of things happened. A little bit later, I will talk to you about the Outer Space Treaty of 67. It's quite incredible to think of the amount of policies and laws that were created and the establishment of councils and the analysis that were launched simply to understand what could be done in the space sector in a bracket of not even 10 years. So after COSPAR was created, and my next slide is to explain to you exactly what COSPAR is, so stick with me. COSPAR established a consultative group of potentially harmful effects of space experiment. And the first spaceflight missions to use this code of conduct were the Ranger missions in 1961, which were missions to orbit the moon, visit the moon, I would say. Since then, all planetary missions have had to implement planetary protection measures at different degrees. And what I mean different degrees, it means that sometimes you only have to do simple documentation about planetary protection. Sometimes you need to put your hard drive into an oven. So those sterilization levels are all dependent on the mission that you're doing. And I will explain those various categories of planetary protection in a later slide. And finally, in '64, so again, not too long from 1958, more detailed quantitative regulation, in particular for Mars, were adopted by COSPAR in '64. So this picture on the right that you can see is the picture of Joshua. If you want to feel good or bad about yourself, he got his Nobel Prize in medicine at 33. It's fine. And when Biospheres Collide, this book that I posted here, it's the history of NASA's planet protection programs. Very helpful book if you want to know more about planet protection. Obviously, I will tell you more about the international structures of planet protection and of COSPAR, and this one focuses on NASA. But as you see at the time, NASA, the NAS, the UN, COPOS, COSPAR, they all work together on those issues. So in a book, even if it's entitled NASA's Planet Protection Programs, it discusses obviously the international framework at the time. So what is COSPAR and what is its purpose? The purpose of COSPAR, and I'm going to repeat that acronym, Committee on Space Research, by its charter from the International Council for Science, ICSU, the purpose of COSPAR is to promote at an international level scientific research in space, with emphasis on the exchange of results, information and opinions, and to provide a forum open to all scientists for the discussion of problems that may affect scientific space research. The objectives of COSPAR are achieved mainly through the organization of scientific assemblies and publications. So, by the way, COSPAR, the Committee on Space Research, has one large assembly every 2 years, and that assembly is going to take place online this year. I mean, in a sort of hybrid fashion in January. So if you're interested and you want to learn more about COSPAR, if you want to learn more about COSPAR-specific planetary protection panel, which is where scientists expert in planet protection go and discuss the regulations of planetary protection, you can absolutely join in and register online, especially if you're a student. I think they have quite low rate to this year because of COVID, and you'll be able to learn much more about the structures and the decision makers at COSPAR as well. Finally, if you're a young researcher and you are doing space research, it is a great conference to meet your peers. In general, if you want to understand the difference between various conferences, the IAC, International Astronomical Congress, which is pretty much, I think, started today and continue. I think the official launch is tomorrow, online and free this year. Well, this place, the IAC, you'll find a lot of space science, space policy, space law, space engineering. COSPAR is very much focused on space science. It's only space sciences. So within COSPAR, what is its original organizational structures? Well, it has scientific commissions representing each and every scientific discipline involved in space research. And I say here scientific discipline, not social sciences, so you won't find a lot of policy and laws panels on COSPAR, but that is changing a little bit these days. And panels, such as the one on planetary protection that we'll be talking about. And those panels are designed to deal with cross-cutting issues that can affect particular segment of the international space research community, and often for which there is an urgent need for input. So you can imagine in 1958, with the creation of COSPAR, with the creation of those panels and groups to think about planetary protection, well, that there were going to be discussions within COSPAR about those new guidelines that needed to be established for planetary protection purposes. And this is this little image here on the right. You can see that there's the service to the international space community, and that comes through education and outreach, publications. COSPAR has 2 reviews, including Space Research Today, where the International Planetary Protection Handbook is published and downloadable for free. And again, the links will be in the last part of this presentation. And you have the scientific assembly, the panel on planetary protection, and the off-assembly years with symposia and capacity building workshops. So all of this is available to you, and I hope you'll get a chance to get involved with COSPAR. So how does it work when you have this technocratic system with scientists who need to build a policy? Well, there is a sort of cyclical work going on. So COSPAR has a planetary protection policy. It has a COSPAR bureau and a council endorsed version of this publication. But then there is a new phenomena reported, new missions proposed, other external considerations, and I will give you the example right now that there are discussions within NASA to potentially change the categorization of the moon that has been category 2 for a long time, and now that is potentially, at least some parts of it, moved to category 1. And those based on the results that from experiment and scientific missions. So when that kind of information comes out, then that new phenomena, you will bring together a new COSPAR-sponsored workshop where you will have solicitation from space agencies and the National Scientific Institution of International Scientific Unions or International Scientific Union that get together and send in their scientists to be able to discuss. Then, when those discussions have brought new ideas, it is raised to the panel on planetary protection meeting. So the panel business meeting at COSPAR scientific assemblies or dedicated COSPAR panel colloquium involved representative of the scientific community and other relevant stakeholders to discuss those new discoveries and those new workshop results. Finally, when that is approved and discussed at the panel will make recommendation to the COSPAR Bureau and Council. And all of this, again, organized, led by scientists. And you do this cycle once more when you have new phenomena and new discoveries. So when it's the panel recommendation are brought to the Bureau and the Council, then you have an update of the policy and you restart the cycle when there's a new information. One thing that is important, because when you think about space law and space policy, you always need to think about the boundaries of space law and policy. So where does the power of COSPAR starts and ends? So COSPAR planetary protection policy does not describe how to implement the requirement, nor does it describe or require a certain organizational structure for the implementation of the planet protection policy. Both aspects are under the discretion of the user, meaning the national space agencies. What this means is, when you have a planet protection policy that tells you, well, there's this amount of spores, that amount of spores for this kind of mission, this is category 1, this is category 2, this is category 3. Well, the implementation of those requirements, how you reached that amount of spores, the kind of decontamination that you do, and all the technicity behind it, well, that's not COSPAR that regulates it. Those are the space agencies themselves. And it's exactly what Afshin was telling you about. At JPL, they have their own protocols. Their protocols end up matching the planet protection guidelines, but COSPAR is not dictating to space agencies how to reach those requirements. Same thing for the organizational structures. In the link that I'll give you in the third part, I will send you, there's a link for the PPOS website where you can find different PowerPoint presentation on the structures at NASA, the structures at the European Space Agency, ESA, the structures at JAXA in Japan, and the structures at CNSA in China. And you will see that you have a variety of different structures. We know already from the beginning of this presentation that you have at NASA and at ESA planet protection officers, but sometimes they're not, you don't have an office that is called the planet protection office within an agency, but you're going to have the equivalent of a planet protection officer somewhere else within the chain of command. So that's also because you have the variety of structures that the Planet Protection Handbook got created, because we wanted to do a state of the art of what is going on and who is making decisions where and when. But COSPAR is relatively stable. As you see, you have this cycle, and they do not care about the implementation and the structures. That is not the job of an international council for science. So when we say that COSPAR is implementing and is developing a planet protection policy, it is following Article 9 of the Outer Space Treaty. And the reason why, if you haven't heard about the Outer Space Treaty before, welcome to Space Law 101. And the Outer Space Treaty was created and co-signed in 1967. And to this date, it has 110 signatories. So you can see on this map, all the countries in green are countries that have ratified the Outer Space Treaty. It is rare that a treaty would have such a wide array of actors who agree on it. So that's also why these days, if you have some discussions and you hear, oh, we're going to get out of the Outer Space Treaty, we're not following the Outer Space Treaty, that's usually not relatively true, simply because all actors and all signatories of the treaty agree that it is quite flexible, that the interpretation of the treaty enables a wide array of information to be extracted and a wide array of actions to be done based on the way the writing of the treaty was done. And also it is believed that these days we would not be able to get 110 countries to agree on a one joint charter that regulates space research and space exploration. So in the Outer Space Treaty, I'm doing a little bit of Space Law 101. Before we get to Article 9, you need to know the basics of the Outer Space Treaty, which is in Article 1. And in Article 1, I will take a second to read it because it is the most important article of the Outer Space Treaty. It says that the exploration and use of outer space, including the moon and other celestial bodies, shall be carried out for the benefit and in the interest of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all mankind. Outer space, including the moon and other celestial bodies, shall be free for exploration and use by all states without discrimination of any kind, on a basis of equality and in accordance with international law, and there shall be free access to all area of celestial bodies. There shall be freedom of scientific investigation in outer space, including the moon and other celestial bodies, and states shall facilitate and encourage international collaboration and cooperation in such investigation. And that last sentence is quite important because it completely echoes the creation of COSPAR 10 years prior, because you have at COSPAR, you have scientific representatives in an international organization to coordinate the cooperation and collaboration of space scientists. It also echoes, obviously, the creation of UN COPIOS, where at the UN level you will have those state representatives to discuss cooperation and coordination of scientific space investigations. So now let's get to the core of the talk. The Article 9 of the Outer Space Treaty. This is what will tell you what to do regarding planet protection. But one thing that you will tell me, because that's what anybody says to anybody working on space law, it's gonna sound vague. If the first article didn't sound vague to you, you will see that this one sounds even more vague. So I will read it. It's a lot of text, but you'll see where we go. And I just want to point out that this is a piece of Article 9. It's longer than this. I wanted to save some time, but I invite you to go on the UN website. You can type Outer Space Treaty Article 9. It's just a little bit longer than this, and it's worth reading, especially if you're going to work in the future on planet protection. In the exploration and use of outer space, including the moon and other celestial bodies, state parties to the treaty shall be guided by the principle of cooperation and mutual assistance, and shall conduct all their activities in outer space, including the moon and other celestial bodies, with due regard to the corresponding interests of all state parties to the treaty. State parties to the treaty shall pursue studies of outer space, including the moon and other celestial bodies, and conduct exploration of them so as to avoid their harmful contamination and also adverse changes in the environment of the Earth resulting from the introduction of extraterrestrial matter. So I'm going to stop there, and this is what we talked about already, the role of COSPAR, the role of the planet protection policy. Avoid harmful contamination of the body itself, and COSPAR being a scientific organization, the way it interpreted it was, well, we're going to avoid the harmful contamination of our science. We're trying to find find life in the universe. We're going to make sure that the experiment that we're doing don't get false positives. So this is why we're protecting harmful contamination. There is no discussion within COSPAR as a scientific committee about the ethical aspects of planetary protection for the body itself. Let's say as a Greenpeace sort of group for Mars. Let's not contaminate Mars because Mars is a different planet than the Earth, and we do not know who might live one day on Mars and who might have lived one day on Mars. So we should not touch Mars because this is a different planet than the Earth. We have nothing to do with it. That in some ways can be extracted from the Outer Space Treaty. You can think, wait, we are in charge of the harmful contamination of that other environment. But this is not what COSPAR does. You actually have an other committee, I think within COSPAR, but that is not the Planet Protection Panel, focused on space exploration that looks at the ethical aspects of it. But today we're focusing on the false positives and the scientific aspects of planetary protection and life detection. And finally, the last piece of it here, and I wanted to highlight this one because it says that this research shall undertake appropriate international consultation. So here again, you have this incentive from the Outer Space Treaty echoing COSPAR, echoing UN COPIOS, etc., saying we are all in this together. We need to discuss and collaborate all together. And I think right now we're going to answer, I think it was either Christine or Lisa's question about, which I saw prior to jumping into my presentation, about the role of the private space sector. Well, the role of the private space sector is regulated within Article 6 of the Outer Space Treaty. Space parties to the treaty shall bear international responsibility for national activities in outer space, whether such activities are carried on by the government agencies or by non-governmental agencies. This is it. If a private company does something in the space world, they have to follow the laws and guidelines from their national organization, national agencies, which can be in the US, NASA, the FAA, the FCC, etc. And to be able to do anything in space, they require authorization and continued supervision by the appropriate state party to the treaty. I hope this is clear, but we can go back to it later on. But it was just to address the private space sector. And I think you've all seen this picture from SpaceX. And if somebody tells me, well, SpaceX or Elon Musk didn't care, they just threw a car at Mars and they did not even decontaminate it, well, I'm sure Ashvin will be able to tell you that this is not true. And I will tell you that on the law and policy side of things, SpaceX had to provide required information to its state agencies, so within the United States, to prove that the car was not going to go and crash on Mars, that if it were to get to Mars at a certain point, enough time would have had spent for the decontamination of the car to be done pretty much by solar radiation and space radiation, and that the object itself had followed some decontamination protocols. Finally, if you are interested in space law, this is a wonderful field. None of this is related to plant protection, so I'm going to skip it relatively quickly. But after the Outer Space Treaty, you had 4 more treaties: the Rescue Agreement, the Liability Convention, the Registration Convention, and the Moon Treaty. So I'm leaving it there. You have some little summaries about each of them if you are interested. And obviously, if you have any question about space law, you can reach out to me after this talk. But now let's go back to COSPAR. Now we know that COSPAR follows what it says in the Article 9th of the Outer Space Treaty. So that's the COSPAR policy. COSPAR maintains and promulgates a planet protection policy for the reference of spacefaring nations to guide compliance with the Outer Space Treaty. United Nations COPIUS 2017. Doesn't mean it started in 2017, just mean that UN COPIUS reiterated the role of COSPAR at the UN COPIUS Assembly in 2017. And so to follow Article 9, you follow COSPAR guidelines, and then the national agencies will have consultation and work at the COSPAR level and then among themselves to establish potential national policies. And again, here as an example, within NASA, you have the development of its own national planetary protection policy, which will follow in ways the COSPAR guidelines, which should follow COSPAR compliance and guidelines, but which will deal with organization and implementation of those guidelines. And so here we're going to talk about the 5 main categories of planetary protection. Category 1 is when you have an object and you say, okay, this is COSPAR plane protection, category 1. What does this mean? It means that you're talking about missions, flybys, orbiters, or lander that go to a target body which is not of direct interest for understanding the process of chemical evolution or the origin of life. So, for example, metamorphosed asteroids, maybe not all of them. For asteroids, it's on a case-by-case basis because maybe some come from places we don't know and have things interesting that could inform us on the origin of life. But metamorphosed asteroids are believed that not to have that. So when you're sending something to a body where you have no interest in detecting life there, then you are a flyby, orbiter, or lander, you're category 1. And this is what the moon could be moved to category 1. Some places on the moon could be moved to category 1 because we could land on places on the moon where we know that first we would not do any research on the origin of life, and we believe that there's no information there that we could contaminate. Category 2 are for missions to a targeted body where there is a significant interest. So now you're looking to find chemical evolution and the origin of life, but where there is only a remote chance that contamination carried by a spacecraft could compromise future investigations. And there is a little note, number 1 here. Implies the absence of environment where terrestrial organisms could survive and replicate, or very low likelihood of transfer to environments where terrestrial organisms could survive and replicate. So when we hear, a small chance, a big chance, to calculate the amount of spores that are allowed or that need to be decontaminated from a spacecraft before being launched, it's all about a calculation also of probabilities. So you need to take a certain list of elements and make sure that based on those elements you have a percentage, and that percentage does not go above or under a certain ratio. For that detail, again, there are fantastic presentations available on the internet that will give you the exact exact list of things to calculate to make sure that you follow the guidelines for category 1, category 2, category 3, etc. Category 3 right now is flyby and orbit missions to a targeted body where there is chemical evolution or origin of life interest, and for which scientific opinion provides a significant chance of contamination. So you go from there is no life and we're not looking for life. We're looking for life and there might be life, but we think probably not. We are looking for life and now we are pretty sure actually there is a significant chance of contamination, so we need to be extra sure. And then category 4 is for the landers. So the flybys, the orbiters, they're not in direct contact with the object, except when there is a reentry, and then you have also the calculations of how the object itself is going to be decontaminated through the heat from the reentry. But for category 4, when you know that you're going to land on a target body and that your goal is to find life, then and that target body is known with a significant chance of contamination, then you need to go category 4 and decontaminate obviously even more. And we're talking here about lander missions to Mars, Enceladus, Europa, etc. And finally, category 5 is for any Earth return missions. So you have the unrestricted Earth return. That means that we talk about solar system bodies deemed by scientific opinion to have no indigenous life forms, like Venus, Moon, etc. And restricted Earth return with Mars, Europa, Enceladus, etc., etc. So that's all about bringing samples back from the Moon or Mars or elsewhere. So as you see, when we're going to bring samples back from Mars with the 2020 missions, we'll talk here about engines that were decontaminated at the level of a category 5 restricted Earth return because we knew that we wanted to bring samples back. So the things for you to keep in mind: planetary protection is about protecting science and the Earth. Planetary protection regulations are based on the UN Outer Space Treaty, Article 9 specifically. COSPAR maintains a planetary protection policy and associated requirements to guide compliance with the Outer Space Treaty. Countries maintain compliance with the Outer Space Treaty Article 9 by following COSPAR planetary protection policy. Human-associated contamination needs to be understood and controlled. A mission planetary protection categorization is based on what is known by the scientific community about the visited body in question. And planet protection categories and requirements are consequently not cast in stone and evolve over time as new information become available. For example, check the latest version at the start of your project. Right now, if you are to launch something to the moon, you need to check what is going on in terms of planet protection research and that discussion between category 1 and category 2. Planet protection engineering requirements are designed and agreed upon through a series of scientific workshops at COSPAR, within NASA, within ESA, etc. And then it goes into this loop at the COSPAR Bureau and the COSPAR Planet Protection Panel that we've seen in previous slides. I am going to stop for a second, just if I can. No, I can't. I will ask Ashvin to, oh, actually I have my phone. I should just check my phone. I want to make sure I'm still on time. Okay, we have plenty of time to talk about the lessons learned, the do's and the don'ts in planet protection management. Because now you've kind of understood that there are 5 categories. You understand COSPAR and that it has a policy and that it is established at an international level with a large group of scientists that you can be part of if you're interested, and then that it establishes the national guidelines that are implemented at different levels. However, because it varies depending on the country, you're going to end up with problems of management. And when we worked on the Planetary Protection Handbook, it was much less about a lack of scientific data and much more basics of management that created problems when applying planetary protection guidelines into a space mission. So even if you're not a planetary protection officer and you do not end up calculating the amount of spores, one thing that you can provide as an expert in the field, as a scientist that will, or social scientist that is going to become involved with the world of planetary protection and sending missions to space objects, is to get some basics on management. And this is what we did for the Planetary Protection Handbook. We sent out surveys in different labs all around the world to get information about what went wrong. And this is when we saw that most of it was management issues. So I've prepared 2 slides to tell you all the don'ts and 2 slides to tell you all the do's. And the do's are pretty much a checklist. So if at any point in your future you end up in some ways involved with plant protection, you can go back to that checklist and make sure that you stay on point. So, in the don'ts, the main problem was an unclear chain of command. And that is that, you know, we've seen this cycle at COSPAR. We know that they are national institutions and that they have their own structures. But in a lot of places, as I said, you don't have one planetary protection officer. You have some scientists that are going to refer to either the ESA planetary protection officer or the NASA planetary protection officer, or going to contact the chairs of the COSPAR planetary protection panel. But then within the structure itself, you don't always have the same organigram, as you would say in French. Hopefully that translates into English. So one of the main problems was a blurred definition and or a severed link between the planetary protection officer at the agency level, and again, doesn't exist always, and his or her planetary protection manager, meaning at the subcontractor level, leading to difficulties in meeting planetary protection requirements. And I apologize if a lot of time you see PP, it's just the short version for planetary protection, because otherwise we say it at least 75 times in this presentation. Another big problem was lack of planetary protection supervision along the entire project, leading to miscommunication and difficulties in handling contingencies. Finally, in this unclear chain of command problem, you had planetary protection relevant personnel who were not convened at key organizational project meetings, creating conflict at all levels between scientists, engineers, technicians, and management, and generating difficulties again in complying with planetary protection requirements. Planetary protection subcontractors end up out of the loop, which can lead to design flaws as the hardware and other parts could not handle DHMR, dry heat microbial reduction sterilization. When I tell you that at some point the hard drive, the hardware needs to be put into an oven, well, that's what we're talking about here. If you do not take into consideration, there is nobody in your team doing the planetary protection basic research on the categorization of your mission and the requirement of that categorization, the national requirements that you need to follow, then you develop you build a design, you develop the hardware, and then it breaks into the oven, and that makes a lot of loss in time, a lot of loss of money. It's just a mess. Simply by organizing your team, you will be able to solve that issue. Another major point was that, as we just said, in some ways, planetary protection is not taken into account during mission design. And I'm not just talking about the hardware. The entire mission design need to take into consideration planetary protection. If it's not, the selected material cannot handle sterilization. It forces the team to start over. As I said, it costs money and delays, but also you end up with sometimes short-staffed planetary protection teams. The right amount of personnel was not requested or not approved by the project manager, and that leads again to difficulties details going unchecked, deficiencies in documentation, difficulties in reaching the PPE requirements. And another point that I could have added there is that, you know, those moments where you need to put your technology into an oven need to be scheduled. So if you're a type A person like me and you like organization, if you have skipped in your whole program, your whole mission design, an entire calendar of things to do regarding planetary protection, and you realize them too late, then it can really create problems within your mission. A third point are project budget overruns, because obviously project financiers are not aware of PP requirements, so that leads to mistake and in finalizing the cost, because you need to think about the personnel that you're going to hire. You need to potentially redo your hardware because it could not handle the heat. You have resources in AIT, assembly, integration, and test plans that were not taken into consideration. And usually when you skip a step, they're not going to throw away the $1 or $1 billion mission, but you're going to have to redo things over, and that costs a lot of money. So when some people tell you that planet protection costs a lot of money, it is true in some ways, because a lot of the time it's less planet protection, but it's planet protection mismanagement that is going to cost a lot of money to a space mission. And finally, lack of training. You do not want to get into a planet protection project when a project manager, a mission manager, or the planet protection team lead do not have previous solid planet protection training, because it creates difficulties in understanding and therefore handling planet protection requirements at the right stage within the project, ultimately leading to failure in matching planet protection requirements. So basics of management, I know, and I'm sure when you read this list, you would say, I would never do this, but it happened again and again. So this is when at some point we wrote a whole chapter about it in the handbook. So now, the do's, instead of reading the don'ts and focusing on the negative, it is quite easy in some ways to just establish a checklist for yourself of planet protection management steps. So first, you establish from the very beginning clear planet protection roles and responsibilities. Who is your point of contact within your National Space Agency, and the person who is in contact with the COSPAR Planet Protection Panel usually. You need to make sure that your subcontractors are in contact with them as well, and you designate dedicated and experienced planet protection staff at all levels, at the space agency level, at the project level, and at the contractor and subcontractor levels. Then you plan adequate planet protection training for your staff, from the managers to the deck staff, because sometimes you're going to end up, and it was quite strange to see that in results, but in some ways it makes sense. We ended up seeing that the managers would go to the training, but not the ones who were actually doing the swabbing to make sure that they were not, the amount of spores was under regulation. So you need to make sure that your entire staff follows those trainings. And they're usually 2.5 days. They can be given at NASA, at ESA. You can also sign up for specific workshops, and it's not, I think ESA and NASA ones are just once a year, but they might have been doing more these days. So it's to put into your schedule, but it's not unfeasible. Plan an early planet protection meeting with all the agents involved in the mission, the planet protection officer, the program executive, the program management, project management, program scientist. Okay, I'm not going to read the list, but you get it. Everybody involved in planet protection needs to be in one meeting at the very beginning. This way you avoid all mismanagement. And designate one person per project, and it might be you. That could be your, you could volunteer to do that if you're a good link usually between people and you like to create those kind of links. Well, it is very helpful to designate that one person with the responsibility of acting as the designated link regarding planet protection issues at all stages of a project. And finally, discuss technical aspects, material selection, and hardware design so it can tolerate planet protection sampling and decontamination into the ovens and match the PP temperature compliances. Discuss the budget, taking into consideration the needs in personnel, various levels of training, and price of selected sterilization facilities and material. Take into account the fact that there will be contingencies. In space, things go wrong. On Earth, to prepare for space missions, things go wrong. So if you have a very, very tight schedule and you've only planned for everything to go right, you're going to get into trouble. So always plan some time, and that does not only apply to planet protection. I will say do this for all of your projects. Plan for things to go wrong and for time to fix those problems. And finally, discuss possible changes, for instance, a change in hardware redesign. This way, alternative planet protection procedures can be prepared in advance and will avoid overcost or delays. So this is it. You have your basics of planet protection policy now. You know how it relates to international space law, because just for you to know, in the way space law is organized, you have international public law, and part of it is space law. And then you have national space laws. So as part of the Outer Space Treaty is part of international public law. So now you know the links between international public law, subsection space law, and COSPAR and Planet Protection Policy. You know what COSPAR is about. You know what to do. If you become a Planet Protection Manager, or you join a mission team where there is planet protection to be handled, and you could be a very key asset by just knowing that basic kind of knowledge. But also, one key element for the rest of your career, whether you are connected to plant protection in any way, or you continue in astrobiology and never hear about plant protection again. The key point in any field is to know where to find the information. What I'm telling you right now is a summary. It's a 1 hour kind of summary about plant protection, and that should encompass 40, 50, 80 years of people working on the subject and thousands of people and expertise. That's not possible. So one of the rules and one of the key goals for you when you get out of this astrobiology course is to know where to go to get your information. It's not to have absorbed everything at once, especially I speak relatively fast. I know that, and I apologize. I have a French accent. My slides are summaries. This is not enough for you to remember everything. And I don't think anybody will expect from you to know everything about plant protection after an hour talk. However, if you know where to look and where to find this information again, and how to use this information for your future jobs, this is when you become really an asset. So to know more, these are the resources I was telling you about. So planet protection of outer solar system, the PPOS project. This is the project funded by the European Commission to create the Planet Protection Handbook. You also have the Research White Book, which was a book, the Planet Protection Handbook was state of the art, what is going on right now regarding planet protection. And the Research White Book was to look at what is the next step, what are going to be the difficulties when we go to Enceladus and the other icy moons, etc. And under PPOS activities, this red circle here, you will find a list of all the tutorials that we've done at CAST, at JAXA, at Caltech, and in Bremen. And you can click on it and you will find all the PowerPoint presentations. Today, this was a summary, but you can find PowerPoint presentation about the COSPAR Planet Protection Panel. You can find presentation about exactly the structure of planet protection at NASA, ESA, JAXA, CAST, etc. You can find so much more information just by going to PPOS activities, and then you select any of the tutorials. And to be honest, we haven't changed it a lot. So when we went from Bremen to Caltech to Japan, some of the presentation obviously repeat themselves, because in a span of 6 months, the organizational changes were not that many. So you can just go to the last one, to the CAST one, which was held, I think, in October 2018 or 2019, and you can download all the presentation there. In addition to that, you can click on this link, sciencedirect.com journal, Space Research Today. And as I said, Space Research Today is one of the COSPAR journals, scientific journals, and they made available for free to download the entire International Planet Protection Handbook. And finally, if you want to know more specifically about COSPAR, I invite you to go to their website. They also have a subsection that I added here on the COSPAR Planet Protection Panel. So those are the online resources to support what you've learned today. But also, and now this is the moment I sell my soup. No, I'm kidding. But there are tons of things going on regarding space law and policy at Harvard. I still work on planet protection. I focus more of my time right now on planetary defense, which is a real passion of mine. But if you're interested in any way, if we put aside planet protection for a second, in what we talked about today, in understanding the managerial structures, in understanding the design of policies, in understanding what makes action and the application of space research possible. If you want to know more about space law and policy, there are plenty of things to do at Harvard. I have had the pleasure to join this university in 2017, and since then coordinated and helped found the consortium between Harvard and MIT, the Space Consortium, where my role is pretty much to know what's going on about space research in all the different Harvard schools. So at Harvard Law School, I teach. It is closed to only Harvard Law School students, but I teach also a course on space law and policy at Harvard Summer School, and there is a form here if you want to be put on the waiting list, because this is open to all people all around the world. The Harvard Faculty of Art and Sciences has new classes that we're designing. You can also purchase for something the equivalent of $5 excellent case studies on the economics of space research at Harvard Business School. You can join for free the Harvard Center for Astrophysics, Harvard and Smithsonian online web conferences that are going on, I think, every third Thursday of every month. And Harvard Medical School has a fantastic conference in November on space genetics. And I'm guessing that this year they're gonna do it online. But you can find all the presentations and everything about space genetics from the previous years on their website, available for free as well. And if you want to learn and just be active within the Harvard and MIT space world, I will invite you to Space Week at Harvard that I'll help organize on April 19th to 23rd with our main event, Space Night at Harvard, and I hope you'll be able to connect. We're designing it so that everything is online this year, obviously because of COVID. Other academic institutions where you can learn about space law and policy, you have the Space Policy Institute at George Washington University. Lots of material, again, available on their website. University of Mississippi, McGill, great university in Canada that has the first air and space law institute of the world, or the first as in the mean of number one, and also originator of an institute in air and space law. The International Space Universities has information about space law and policy. The European Center for Space Law has free courses and available seminars, and Leiden Law School, if you are interested in doing an LLM in air and space law. McGill, Mississippi, and Leiden are some of the places where you can specialize in space law. And finally, for your conferences, we've covered this already. You can sign up and join COSPAR in January. Tomorrow, you can join the ISC if you're not too tired from all these astrobiology courses. If you want to know more about space law in general, there is the International Institute of Space Law that organizes great thing on their website. You can Google it. If you're under 35, the Space Generation Advisory Council brings together all people under 35 who have a passion for space, and so you have subgroups working on space research, and this is a great place for you to do some volunteer work and to network and discover the field. And finally, there is obviously the Space for Women program, for which Jen and I are honored to be mentors for this year, and I think this is how I'll finish my presentation. If Jen, I think Jen has already told you about the Space for Women program, but one of the things is that we're working on ending gender inequality in the space sector, and those are the numbers that we usually share. Over 560 people who have traveled to space, only 11% were women, only 15 female astronauts have conducted spacewalks compared to 210 men, over 222 spacewalks and 22 years of progress at the ISS. Only 2 female astronauts finally took part in a singular extravehicular activity last year, and in total, women represent only 20 to 22% of space industry workforce, which is pretty much the same thing as 30 years ago. Not to mention the women CEOs in the space world are only 19% of the workforce. So if you're a woman out there, or if you're men out there interested in the Space for Women program, we invite you as mentors to check out their website. They have plenty of activities. I myself have some mentees, and I organize monthly mentee webinars where I bring in a woman from the space sector who have done a lot for the space world to learn more from them. So if you are interested also in maybe becoming a mentee of the program, or if you are looking to just gain general information about this fantastic initiative, feel free to reach out to Jen or to me whenever. With that, I thank you, and I will stop sharing my screen to start up the Q&A and welcome your questions.
All right. Thank you, Alissa. That was wonderful and enlightening. And I see actually Siddharth is here. He joined the talk. So I'll let him take over to moderate the questions.
Hey, Alissa.
Hello.
I'm really sorry that I wasn't able to join in at the start. I'm actually not in Mumbai. I'm traveling for work. I'm actually in Ladakh, 3,300 meters above all of you. But I was able to listen to about, I think, close to about half an hour, and I'm just in awe of all the information that you have given us. So firstly, at the very outset, I should thank you for taking time out for this. And I could see the amount of energy and passion with which you were speaking. And I think that makes the talk even more effective. So, thanks a lot for that. And also thank you for all the information on the opportunities. In fact, we might take some of those slides because the last session, the last class of astrobiology is actually devoted for opportunities. So we'll make sure that we rerun that information that is from your side. So I see that Afshin has already taken some questions and answered them. So thanks a lot, Afshin, of course, for stepping in and moderating the session on our behalf. Let's see. So how we normally do this, Alissa, is we could do it two ways. Either you can choose the questions you'd like to answer, or I can just read out some of these questions, depending on how you'd like to do it. I see that we have about 8 open questions, so there is a possibility that we can go through all of them. If you have some time with you, that is, for the Q&A.
Absolutely. I'm open to all of the questions.
Okay.
I'm excited.
Perfect. Okay, let's see. So I'll just go time-wise, so chronologically. So there's a question from Ariana. I'm just going to read it out. If a mission violates planetary protections, either through negligence or an accident, example, the tardigrade on the moon from the Bereshit mission, what happens? Is there any way for international community to meaningfully respond to these events?
Ooh, compliance with international law. This is a very good question. So one thing is, if something really major happens, the one court that deals with big international law problems is the International Court of Justice in La Hague. So if there was a very big conflict and two countries were to butt heads, we would say, then the case could go up to the International Court of Justice. But generally speaking, usually space agencies negotiate among themselves. So you've had some examples. You had some international condemnation when there was as you said, the tardigrades on the moon. Usually, and I'm comparing also to planetary defense, you have this question of liability, and that question of liability is usually linked to the intent. So the intent of your action is also very important. If it was something that was a mistake, that is something that could not have been protected from, usually it does not, people do not run to the International Court of Justice. However, a lot of the space sector works in some ways with peer pressure. That's a very interesting side of the policies of the space world. You see the peer pressure, and you see the fact that it's mostly a technocratic system in planet protection and otherwise. So because it's a technocratic system, there is a sort of trust that international space scientists are involved at every single stage. And if there is a mistake, it might have been a mistake in implementation and mistake in management, but you could prove through experiment that this mistake did not have the very serious impact that some could think it had. The media will tell you they ruined the moon or something, and then you go into a workshop on planet protection or a workshop dedicated to how to handle microorganism and forward contamination, and they will tell you, okay, well, this zone now has this and this and that. Now we know we're not going to maybe land there, or we're going to avoid this, or for this amount of time, for the time space radiation acts on it, we're not going to approach this zone, etc. So you have ways to mitigate when there is that kind of accident. But if there is some clear moments where it's, we're not listening to you, we're breaking the outer space treaty, bye-bye, it is a little bit worrisome that you could break international law and you could break the outer space treaty and not immediately get fined or immediately get huge consequences. But this echoes now this first aspect that I was telling you about, which is the system of peer pressure. Right now, the space system is built in a way where it's still too difficult to go there alone. So you will hear of the NASA Mars 2020, and you're going to hear about the Emirates, and you're going to hear about ESA, and you heard about the Rosetta missions and Hayabusa in Japan, etc. But always, absolutely always, in those missions, there is an international component to it. And the way the peer pressure works is, if you're intentionally breaking the outer space treaty, we're signatories and we're not going to align with you, so we're not going to accept your technology, we're not going to accept your experiment, we're not going to help you launch, and you have your own, when you have your own mission and you need my launchers, etc. And this is how that peer pressure works. So you have in some ways a system of self-regulation when you have those moments when law is broken and when regulations are not followed.
Thanks, Alissa. I think that was quite comprehensive. And I see a lot of overlap between questions. So, okay, let's see. What do we have? Let's pose a question. There's a question about Russia's recent news about, when they claimed Venus to be a Russian planet. So I think let's pose a general question here. What about these claims of sovereignty on international territories, and outside? So is it similar to what we have in Antarctica or the open seas? Or is it going to be different in space?
So the link that you made is very interesting, because in some ways, the way space law was developed was out of a limitation from air law. So when you think law of the seas, when you think air law, you're thinking, oh, and now space law. And so we're kind of following that logic, and it makes total sense. And when I say that it was born out of a limitation from air law, is simply when Sputnik was launched, and instead of going at 100 kilometers, it went above the Kármán line, then you're not following air law anymore. And so it's really much a situation when law and policy was catching up to the technology. And we developed those guidelines saying, now we can't focus on laws that were applicable to earthbound and under 100 kilometers. Now we have to design something completely new. In outer space law, what they tell you, which is very clear, and it's in the Outer Space Treaty, go read it, great document. There is no ownership. There is no ownership in space. You cannot own a body. If you go in on an asteroid, you cannot put a flag and say, this is mine. The beautiful American flag with a cute symbol, but it did not mean in any way that the moon was owned by the United States at any point throughout history. So the question now changes with the evolution of space resource management and space resource policies, because you have different ways of interpreting the law. The reason why the Outer Space Treaty is still current today since 1967 is because, as I said earlier in the presentation, there is a form of legroom that is given to this document by the ways some people will say is vague, and I say is open to interpretation. And in this document, it tells you, you cannot own a body. You cannot own this in space. And you have this final, in one of my slides, I told you that following the Outer Space Treaty, you had 4 follow-up treaties, one of which was the Moon Agreement. And the Moon Agreement was very much specifying you cannot own anything, not a space object, not something extracted, nothing. You're not owning anything in space. And that treaty, in some ways, it can be considered as a failed treaty simply because when you look at the Outer Space Treaty, it was signed by 110 countries, sorry, and the Moon Treaty was only signed by 18 countries, none of which were major spacefaring nations. So when the major treaty that tells you you cannot own nothing in space, if you go to the moon, this is World Heritage, you're not owning anything on the moon. When this has not been signed by enough countries, then you can go back to the Outer Space Treaty that just tells you you cannot own space objects, and say, what if I extract something from that object? If I extract it, it's not the object that I own, it's what I extracted from it. And it's an action that I've made myself, and this is something that I get from it, and that's it. And the United States and Luxembourg passed laws saying if you extract a resource from a space object, from an asteroid, let's say, then that resource is yours. And this discussion creates, in some ways, certain tensions, and is openly under debate right now, because you're going to have certain countries that are going to look at the Outer Space Treaty and say, no appropriation means no appropriation of the object, nor what's inside of it. And some will say, if you want to give a boost to the space sector, you need to continue the privatization of the space sector. You need to create an incentive for private space sector companies to invest. And for them to invest, you need to make sure that you promise them that they're going to have money back when they make investments. And a way to make money back is that if we extract things from that object, that extraction can be sold and can be owned by that person. And those two interpretations, in some ways, are valid looking at international law, because law is about the interpretation of the words that are being used. So I cannot tell you which one of the two is right or wrong. This is, you could think about space ethics, which is also a wonderful discipline that we're also developing at Harvard. But in terms of space law per se, one thing is, from the Outer Space Treaty, you cannot own a place. So when someone in Russia tells you that Venus is theirs, it might be a way of telling them that there has been a focus on the moon from the European side. Then there has been a huge focus on the moon over the past 10 decades on Mars. Then there has been this sort of dialogue between the US and Europe saying, okay, we'll get to Mars from the moon, and this is going to be our new focus. And there have been a very little amount of missions towards Venus. So with the Russians having worked on Venus while some others had focused on other things, they can say, well, we own it because we own the knowledge that is currently there because we worked on it a lot, but it's absolutely figurative, and it's not at all legal to say that you own anything in space, especially not an entire planet.
I think that makes absolute sense. Let's see. Afshin, did you want to choose a question? I just need to step aside for like 30 seconds.
Oh, okay. Yeah, these are the questions that are unanswered are mostly policy questions. So maybe I'll just read out something for Alissa. So I saw a question, are there policy, I think it comes under the same thing. You probably answered that, if any country is claiming land over any other planetary body, then how it works. There was this interesting question by Bianca Palombi. I heard that the man-moon missions left waste bags on the moon with human excreta. Wouldn't this constitute as contamination of the moon, particularly if these microbes have survived? And then I know there's a follow-up question by another student that what is being done? Is there any plan to remove these bags of waste because they are potential contaminants?
So I'm thinking now of the ISS, because the ISS is in space, right? And you're thinking about garbage in the ISS, etc. When you think of garbage in space, you can think that you can, in some ways, launch it, or for the ISS purposes, you can throw it out, and through to the Earth's gravity is going to re-enter the Earth's atmosphere. It's going to disintegrate within the atmosphere, and we're done with that contamination. The way it is dealt with on the moon is, I wouldn't say more complicated, but more discussed these days, because you have, for the International Space Station, you have in a specific interagency agreement, and you have those rules listed out, and they figured out what to do with the waste from astronauts, and they even planned if an astronaut were to die on the ISS, what would happen to its body, etc. For the moon itself, you have new organizations like the Moon Landing in Context and the Moon World Heritage. I would invite you to Google those words. I think the last one, I might not get the words in order, but you have full organizations that focus on looking at those landing sites from the Apollo mission and consider them as part of the World Heritage. And if it's part of the World Heritage, you know, leaving trash bags and knowing what to do with these trash bags is a question, and it's currently being discussed. You also have this idea that, I mean, for the moon, and I am not a biologist, I do not have the expertise to know how long does it take for human excrement to be radiated enough so that they don't contaminate things. But I will say that if you look back at the categories of COSPAR, the moon is currently category 2, and we have discussions with NASA about, I mean, the planetary protection, you know, scientists have discussions with NASA about making certain zones category 1. And when we think category 1 and category 2, we're very much talking about paperwork and documentation, because we do not believe that there's life on the moon except the life that we might bring. So the most important with regards to planet protection is to make sure that you do not change the environment that could evolve into something that would ruin your scientific experiment. Now that we know, and there is a consensus internationally that we're not looking at the moon as a space a body where we want to detect life. If we were to bring our own life on the moon, and we've sent astronauts there, we do not believe that it is changing the environment, because there is nothing more to be changed there, because there is no life of its own evolving there. However, it is true that by going there, we are bringing something there. The larger debate comes down to what is going on Mars, because on Mars you have, and we haven't had a chance to talk about it today due to lack of time, but you also have within those categories 4 or 5, you also have the subcategories within category 4, because you also have spatial regions. And on Mars, you don't think that, you know, life is absolutely everywhere. We're thinking that there might be places where you have specific elements that make it possible that you could detect life there. So you would decontaminate your spacecraft in a different fashion, in a more strict fashion, if you were to land near a site where there is a chance that life is evolving, and that's a special reason on Mars. And you can think about that also for the icy moons. You have certain icy moons which has cracks on their surface, and it is believed that if you were to put a lander, if somehow there was some contamination that had not been properly dealt with, it could fall into one of the cracks that would link it to the under-iced ocean, and then in some ways have the potential to contaminate the entire moon of its own. But not all icy moons have those large cracks that link to an under-iced ocean, which is why in the end we go back to a case-by-case basis. For asteroids, for objects, for a same body, for a same planet, you have some planets like Mars with specific regions. You have some icy moons that are different from other icy moons, which is why you have all those workshops and expert groups that work on those very, very specific cases. So for the moon, there's probably a group out there working on the contamination coming out of this potential garbage. But my take would be to say that it is category 1 or 2 when we think about the moon, and that because we know that there is no life on the moon that we are trying to detect, it should be relatively safe to have left that garbage there. Then how to handle this heritage site, and how do we consider what was left, all of what was left in 1969? Well, that I will leave that to the experts in the matter from the Moon Landing in Context groups and the World Heritage groups.
Thanks, Alissa. There's an interesting question from Lisa. Can you explain the difference between patented orbital trajectories, which is intellectual property, versus ownership? There's been quite the discussion on this, and I noticed that it's certainly adding to the confusion.
So the difference between patterns and ownership?
Yeah. Orbital
I would
trajectory, which is intellectual property versus ownership.
So I am not an intellectual property lawyer, but in terms of the specificities, what interests me in intellectual property is that it's the idea and the application of the idea that gives you a patent. When you think about ownership, it's not about the idea of, let's say, I have the idea of owning the moon and I went there and I built a base and it's my base. It doesn't work that way. So ownership of an object is, there is a claim of sovereignty over the object. And this is what the Outer Space Treaty doesn't talk about intellectual property. It talks about the impossibility of having sovereign ownership over a space object. I'm not exactly sure if I understood the question correctly, but I would make that distinction that you have patterns and you have, it's the idea, the application of the idea, and it's based on a technology or the development of yeah, I would, maybe not only technologies, probably some projects can be patterned that are not linked to technologies, but you also have on the other side space law, international space law, and here you talk about sovereignty over a territory.
All right, thank you. There's a question that's saying, do planetary protection policy also applies to the ISS microbiological experiments? So yes, the experiments are controlled. I just wanted to point out this difference that yes, we do take microbes to space to experiment and do all kinds of studies on the ISS, but these are controlled experiments. These are not considered as contaminants. However, the environment of ISS itself, because it's closed, the microbes that live on human body, they of course hitch a ride to ISS. And there is actually a specific group at Planetary Protection at JPL that does this study, that just studies the microbiome of the ISS, mostly because we're interested to keep the astronauts safe up there while they stay for long haul space missions, and to study the interaction if they can potentially be harmful in a closed environment, and what any biofilm formation that's taking place, what can those do? So yes, there are different segments to it, but any experiments that are sent from Earth, they are highly controlled. So those are not considered as contaminants.
And I'll say that do not trust the movie Life. If you've seen it and you think that there are mean aliens developing that are just attacking the crew,
yes,
Hollywood has imagination.
That was the worst astrobiology movie or space biology movie I've seen, probably. Okay. So there's one of the longer questions, and Alissa, maybe you can address this. Multiple people have sneaked items onto the space missions without the knowledge of their superiors. For example, Soviet cosmonauts aboard Soyuz in 1978 brought chocolates on board their flight, which scattered in orbit and required 2 hours to collect. Gemini 3 astronauts in 1965 brought a corned beef sandwich into orbit, which was widely publicized in the media. So what are the laws or guidelines for items that are smuggled into orbit by astronauts? That's a fun question.
Can you blame someone for wanting a sandwich and some chocolate? Actually, you can't. This was not the right thing to do. But at the same time, you understand the guy, right? No, I'll say more seriously, that goes back to the guidelines for the ISS. One thing that is interesting is that there is this sort of misconception when you hear about spaceline policy, because you have so many other structures out there. And I'm re-highlighting the fact that it's beautiful that the space sector is developed as a technocracy, because you have so many places out there where the policies and the laws are not reactive to space science. They're enabling it, but sometimes they're even going past it, and you're imagining problems that are actually not occurring. And in some ways, for space mining, we are not exactly at the point where the space mining technology to go in orbit around an asteroid and rotate at its same speed and land on it and extract it, this has not been tested. And you have many more conversation about the policies and the laws to help invest money into the field, rather than, you know, this being driven by the scientists and the researchers, the engineers themselves. However, for planetary protection purposes and for those guidelines on the ISS, etc., it is still led by scientists. So it's not going to be an international space lawyer or someone at the White House who has no space policy background who's going to tell you, you know, they ate a sandwich in space and they brought some chocolate and this is, you know, a huge diplomatic crisis. The first question is going to be, scientifically speaking, is it actually putting in danger the scientific experiment on the ISS? Could this become, you know, gain velocity and hit something and not deintegrate easily? Can this attack one of our assets? And those are the questions that are going to be asked. If it does not escalates, is because there was a scientific and engineering answer to it. So I do not know about the sandwich or the chocolate, but I would guess that if at this point you haven't had an international crisis, is because on the scientific and engineering ground, it was proven that the crisis in itself was absolutely manageable.
All right, thank you. What if any country collects resources? Does that come under space law?
In some ways it does.
Asteroid mining, yeah.
Yeah, it does. When we talk about asteroid mining, when we look at Article 2 about non-appropriation of space, and then it connects to the discussion of the Moon Agreement, and the fact that for the Moon Agreement, it's no appropriation, but also no use of what is collected. What is interesting is that at the time the Outer Space Treaty was written, you had, we're thinking about 4 pillars, and that's something that is explicitly explained by Martin Elvis in one of his recent articles. I can send Sid and Afshin the reference, but the explanation is that there are 4 pillars into space research. You have the space exploration, space science, you have human habitats, you have now pretty much the private space sector, and planetary defense. And out of those pillars, at the time of the Outer Space Treaty, you really had a focus on the science. You need to imagine a document from 67, and you can see it. It was echoing the creation of COSPAR in 58, and UN COPOS, and ICSU. All of this was happening. You had a Sputnik in 57, and then for 10 years, it was a lot about what do we do? How do we organize ourselves as scientists doing science and engineering? And now we're moving towards a variety of pillars where it's not, the focus is not just space science and space exploration. It's about human settlement. It's about planetary defense in some ways, and it's about the private space sector privatizing some activities in space. When you think about extraction of resources of an asteroid, you don't think, I mean, we could imagine that there might be some scientific research being done on the extraction, like any sort of sample return, but a private investor investing in a company like Planetary Resources, which went down in 2017, but that's just an example. They are not investing because they're thinking, great, we're going to get some great science out of it. They're investing because they're thinking that lithium, if you have some elements that you're extracting that are rare on Earth, you can sell them and make a lot of money. So it's that change in discourse, it's just that change in objectives that is very much impacting what we're doing today. And there is this tension building, not only because the Moon Agreement was only signed by 18 countries, not only because the Outer Space Treaty says something that is open to interpretation, because that's a good thing about the Outer Space Treaty, that it is so flexible. But you have this tension built between an interpretation of the Outer Space Treaty that is solely focused on space science. And then if you only focus on space science, you say, well, we want scientific research. That's our goal. So we're going to go to an asteroid, we're going to mine it, we're going to extract it, and we're going to analyze this, and the results will be public to the world to know. And from that result, we'll be able to develop even more research on small bodies of the solar system. This would not break the Outer Space Treaty. There would be no tension. People would agree on that. The difference now is, what do you do if you have a private actor who wants to extract that resource and not use it for scientific purposes that will be used and shared with the rest of the world, but to use it for capitalistic purposes? And that's okay too. It's a way of bringing money into a system that nowadays is changing its business plan. You do not have, NASA doesn't have the budget that it had in 69, and you have the rise of the private space sector in some way as a form of equilibrium because the public sector is not investing as much as it did. So there is a change in the structure, there's a change in the formula, and that brings new debates. But you will not have international space law run after people because they want to extract resources. You will have debates at the international and national levels between space scientists and engineers, and also bringing in people in the space law and policy world. And hopefully decision will be made by people like you who are space scientists and engineers who are informed about the laws and policies and the ways to interpret them.
All right. Thank you, Alissa. So I'm seeing a few questions that are along the same line. I'll make that the last question, and
Afshin,
just
and Jen rose her hand.
Then you're muted.
okay. Maybe
you're
we've
muted,
gone
Jen.
way over time. Yes.
Thank you. Thank you. I just wanted to bring it back to an Earth focus for a moment. And Alissa, I just Googled like how many countries have signed the Treaty for Outer Space, and it said 110, although not that many ratified. And you may have mentioned that, but that factoid didn't stay in my brain. But anyway, something that I've just learned in the past few years, that in order to be considered a spacefaring nation, you need to have launched something into space, or have paid another company or private enterprise to launch into space. So are there the same kind of planetary protection guidelines for cleaning those satellites, whether it's a CubeSat? I'm thinking of something that's a much more frequent occurrence, right? A CubeSat or a small satellite, are there the same sort of cleanliness, microbial load threshold guidelines that are required for launching something into Earth orbit? Because this doesn't really pertain to other planets, but certainly it could be a mechanism for launching something that could be hazardous to life on Earth from another part of Earth, right? If it's going to come crashing down.
That's a very interesting question, because it connects a lot with the notion of space debris and the legal and policy aspects of space debris. Because nowadays, through the IADC, the Interagency Debris Coordination Group, you have guidelines similarly to what COSPAR does for planetary protection, which really focus on when you want to, test and find life in outer space. You have guidelines, similar guidelines by other groups like the IADC on topics such as space debris. And so when you send satellites into space, you don't decontaminate them at the level of planetary protection, of the planet protection guidelines, because a satellite is never meant to do a flyby or land on another planet which may contain life. However, you need to make sure that you have contingency plans for re-entry, because you do not want to send something and then it re-enters. And we're not talking about satellites, but we had cases of full stages of shuttles who broke and fell and did not completely deintegrate and fell on Chile. Usually you have a plan for them to fall into the SPOA, the South Pacific Ocean Unpopulated Area. And there you can think about the Mir station, which was doing experiment, and that was planned and was re-entered into that zone. You had the Chinese space agency, the Chinese space station, the older one, that was brought into that same zone. And then you have obviously the ISS. If at some point we deorbit the ISS, it will fall into that zone. And we want to make sure, obviously, that things are broken into pieces in a specific way to make sure that there is good re-entry and good breakup, so that you do not bring certain elements heated in certain ways that we could not have predicted into our oceans. So you have, but that's much more linked to space debris guidelines than it is about planet protection guidelines.
Okay, thank you. And that's similar to, I see this question in the chat from Abigail, just saying, is there any legislation to stop very rich people launching as many satellites as they want?
Satellite constellations. Well, no, but there is, because when we go back, I'm very happy I put in Article 6, even though it wasn't obvious, because when we think about planet protection, we often only think about Article 9, but Article 6 of the Outer Space Treaty saying that the state is responsible for the action of its non-government entities, it's very important. So yes, a company is liable and has to follow guidelines from its own country about the amount of satellites that they're sending. And right now, when you have a company that sends, hundreds and hundreds of CubeSats, so small satellites, they need to comply certain guidelines to make sure that there is re-entry and that there is that they disappear into the atmosphere when they come back. And they also follow specific guidelines, at least as an example, at NASA in the United States, following FCC guidelines for the commercial, the Federal Commercial Office, and FAA guideline, the Federal Administration Office, Aviation Administration Office. And so you do have that. You do not have a rich person saying, I'm going to launch something in space, because to do this, you need licenses. And for those licenses, you need to register under a specific department that needs to connect with the UN. And every single object that is launched in space needs to be registered at the UN. And usually for the US, for example, it's through the Department of State. The Department of State has a catalog, and every time someone applies for launch and gets a license, the Department of State need to register that launch and that object and inform the UN about this. And all countries signatories of the Outer Space Treaty need to inform every time there is an object in space, so that we can track them for maneuvers purposes if they run into each other, or space debris purposes. We need to know what's out there.
Even the military.
Yes, even the military is supposed to. Obviously, you have those discussions of, the military would never, but it is, and you have those dark satellites. I'm not an expert in those. However, I will tell you that you have fantastic research done by think tanks. You can think of SP, the European Center for Space Policy, and Secure Well Foundation, who are private space think tank who will look and make studies for the government and for other governments to be able to learn a little bit more, and for the general public to learn more about the action of the military in space and how those satellites can spy on each other, how they can share data with each other, and those strange activities that some satellites seems to be having sometimes.
Wow, I can see endless discussion about all these topics that are constantly evolving. So interesting. I was just thinking about, for example, all of the small fleets of small satellites launched by, say, Planet or by Blue Origin or Google, and how that just complicates everything. Or about companies like Rocket Lab, who is essentially an international company because it's filed, or its business license is filed out of Delaware in the US. And so that means it has to comply with all of the USA guidelines for launch from New Zealand. Anyway, it's very interesting and very complex. So this is really fascinating.
I am putting in the chat right now because it's in the slides and you'll get the slides, but here's the link for the interest form for those, because I can see that you like planetary protection, but you like spaceline policy even more. So if you are interested, so that I have your names and I can keep you posted on the courses that will be made available, this is the interest form, and I'm just going to type again my email address. This way, if you have any further questions, I can't answer quickly because I usually have a lot of questions coming my way, but I will try to get to them as much as possible. You can reach out to me on LinkedIn, or you can just send me an email to that address.
Great, and we'll also be taking a note of all the other questions that were left unanswered. And don't feel obliged, but if there's any time that you have and you'd like to put to us, that we'd be happy to receive any question, any answers to the questions that are there. I think we're close to time, Afshin.
Yes.
Okay.
I have noticed a lot of very good questions during the Amity course, Sid, and I've also noticed that there are questions that usually don't suggest a short answer.
Yes, we would have to write another PhD thesis with those questions. So we appreciate the questions, though, everyone.
If your questions are not answered, please don't be offended. It's just that, oh my gosh, or sometimes the answers are known.
It's so hard, we try to make sure.
The answer to all.
Sorry. Go ahead.
Sorry. the answer to all spaceline policy questions are it depends. So it's so we apologize if we cannot give you very specific answers, because it depends every time. It's a case by case basis.
No, you guys, you know what, you spend so much time after your talks with the Q&As. That's just so encouraging. We just try to ensure, the reason why we do this is that it's a bit more interactive. It's just not a lecture that's delivered and then people listen to it and then go back. And because we have so many students who've signed up for this, who at any given point of time, we have about 100 to about 200 students online. And then we've seen about 400 to almost 500 people watch them afterwards, offline as well. So it's just hard to keep it interactive. So even if you're answering 5% of the questions coming your way, we are happy. So that's fine. So I think, yeah,
Sid,
Jen.
Before you sign off, could you give us, or those who are still online, a brief update on the status of the course projects with the vocabulary lists and also the analog sites?
Yes, so we have extended the deadline because we noticed that not everyone was able to is able to have completed it so far, and that's completely okay. So we had one assessment of an analog site. I haven't looked at the current numbers. Tanvi, if you're online, you can tell me if you've looked on. I think about over 100 have filled in the assessment form, or maybe more actually. Tanvi, do you know more?
So I'll have to check about.
Yeah, so we'll get back to you on that, but a decent chunk of people have, and also the feedback forms and the what is the other one? The glossary, the 3 keywords per class as well. So 100 is on the lower side. I'm telling you, a conservative number. It's more than that. I think it's about 140, 150. So we've extended it until the 25th, the deadline for people to do this, so that as many people can, because we also want people to be able to interact and engage. And we've received a lot of good feedback on the assessment, especially the field analog side. And there were people who did it in like a week, and they're like, where's the second one? Where's the second one? And we're like, we can give you 5 or 10, but at the end of the day, what matters to us is numbers. So if 50 people or 100 people are able to give us data, because most of these assessment tasks are subjective. So we're actually looking at a range of answers that are coming back from people, and that's more important to us than just individual assessment forms. So we're just encouraging as many people, to fill that. So the deadline has been extended until the 25th, and also feedback. So I'll just remind all the participants who are listening in to make sure that you fill in the feedback form. That's really useful for us to know how we've done, and also individually for the instructors. And next week, we will have Ms. Annalie Beatty talking to us about some of these human factors aspects. So we go one step further and we talk about what life would really be. What are some of the challenges, social challenges, political challenges, administrative challenges that will be faced by humans when they're living, in space. And I think she's focusing on Mars for communities that are living on Mars. So that'll be an exciting discussion to have as well. And any other questions, Alissa, or anyone else?
I'll say that I've seen while you were explaining this for the assignments, I've seen in the questions someone saying, but you didn't talk about planetary defense. I know, I love planetary defense. I want to talk about it more. I'll just say that if you Google legal aspects of planetary defense, our report on planetary defense issues was published in April 2020. So it's fresh, it's new, it's delicious, and it is available online on the ESA, I think it's ESA SEMPAGE. So if you type SEMPAGE, SMPAG, and you type legal aspects of planetary defense, or just legal aspects of planetary defense, you'll be able to download the report for free. But if you cannot find it somehow, you can email me and I'll send it to you. I just wanted to focus on planetary protection because, again, the two domains really sound similar. And if I were to tell you about Astrid at the same time I was telling you about decontamination, I think you would have messed things up even more. So but obviously, feel free to learn more about planetary defense because it's also a very, very interesting topic.
Does anyone know that, so that IAC, International Astronomical Congress, is starting today, I believe, and going Monday, Tuesday, Wednesday. And this year, it's usually a very expensive conference to register for. And this year it's free because it's virtual. You may be able to, you have to pre-register. you may be able to register also. I mean, even now, in which case there are sections in this Congress about planetary protection and outer space law, and as well as a lot of astronomy and technology for space, and even astrobiology. So if you're interested, everybody, IAC.org. I don't know. Afshin, can you put the link on it, maybe, or somebody?
Yeah.
Anyway, I signed up, and you can search the sessions that might be of interest. Yeah, there we go. Thank you. Thank you, Satya. That's one positive thing about the pandemic this year, is that many of the conferences that normally cost upwards toward $1,000 to register for are free. An exception is COSPAR. I know, because I'm hoping to be in Australia for this meeting, and it's a very expensive meeting to attend. And actually, I'm not going to withdraw my abstract, but I don't want to pay $900 to give a 3-minute talk. So I'm probably going to wait till the following year, which is COSPAR 2021 in Athens, maybe, or 2022 in Athens.
In Sydney, in 2022 in Athens. I will say, COSPAR's only source of revenue, in addition to their papers, is their assembly, so they had to keep the fees. And the Planetary Defense Conference, if you're interested, so only about asteroids, it's going to be in April, and we're also working for it to be hybrid. I'm not sure if it's going to be free or not, but usually I don't work for COSPAR anymore, so I promise this is not a free commercial. But it is true that in those moments you're thinking, why isn't everything free? But it's because certain structures just cannot afford for them to be free. So we apologize in advance for that.
And it takes effort to organize things, and I'm so grateful that we have people from Amity and TAs helping with this course. But imagine if you're trying to coordinate thousands and thousands of people.
Absolutely.
Beyond me. But
I should add, just as a last note, some good things. So I actually looked at the numbers. About 262 people have sent in the assessment for the analog site. So that's way larger than what I was expecting. And we have another 2 weeks to go. So I'm guessing at least 300 people out of 600 active people. So 50% are putting in the effort and doing that assessment, which takes about 30 minutes. I think that's a big thing. And also the other glossary forms. And I've been reading a lot of notes while we've been talking about. There's someone who said this has been the best space law class I've taken this year, and I'm a space lawyer. So that's really great to hear. And also some people saying things like, we don't want this course to end, and this has been one of the most wholesome courses done. So I'm trying to blow my own trumpet and talk about how good this course is. But the reason I'm doing that is because it's not just us, and it's all of you guys. We all need to share, the good compliments that are coming our way. This could not have been done if we didn't have it.
I'd like to say that, so yesterday, actually, on the last day of World Space Week, I gave a talk with the Space Geeks in Mumbai.
Yes, I know, yes.
And I know you were traveling, but they gave a very nice shout out to you.
Okay.
And especially to you for all of your organizational, collaborative and inclusive efforts to bring space to everybody. So it was very flattering to you. If you're up in the high altitude and your ears were burning because we were saying nice things about you, that's why.
Thank you so much. All right, with that, we won't take more time of our participants. So thank you everybody for signing in. We'll make sure that we get the recordings out within the next 2 days or so. And also make sure that you fill in all the assessment forms on time. And we'll see you all next week. Thank you, everyone. I just will request the panelists to stick on for a minute, and we can stop the recording. So thank you, everybody.
And lovely job to my fellow instructors.
Yeah.
Thank you, everyone.
So we're going to stop the recording.